All right, welcome to the introduction to fractions. Let's get started. So with fractions, we are looking at a part to a whole. So with the most basic fraction, that's what it is. You're looking at a part to a whole. Now we'll talk about improper fractions, mixed numbers, and the other kind of definitions that come into fractions in a couple minutes, as we work through this. But at the most basic part to this, we are looking at a part of a whole, or part to a whole. So part of a whole. So if you think about this, fraction works really well if you think about it in terms of eating. So how much that you eat of something. So if you eat half the cake, if you eat a quarter of the cake, if you eat a part of the cake or a piece of the cake, if you eat the whole cake, or if you eat it a lot of times works in terms of like pizza pie, because a lot of like pizza pies are already cut, right? So with pizza pies, they're cut into 8 slices a lot of times. Sometimes more, sometimes less, but a lot of times 8 is the standard. So if we look here, the part always goes on the top, and the whole always goes on the bottom. Now what I mean by that is whole is the number of pieces. Okay, so the part is the shaded pieces, or the shaded amount. And the total number of pieces, the whole, is the bottom. So the top is called the numerator, the bottom is called the denominator. Sometimes you remember denominator down, denominator down. So again, these notes are all denominator, sorry. These notes are all good notes to take as you're going through this. So because they're all words that are going to come up over and over again throughout this chapter. So if I were to write the fraction for letter A, I'll just change my color so that you can see it. We have one piece that's shaded, so that's going to go on the top. And then we have 1, 2, 3, 4, 5 total pieces that are in this circular shape. So my fraction is 1/5. So that would be like, my pizza pie was cut into 5 pieces, 5 slices, and I ate one of them. Okay, letter B. This is almost like another great example is a Hershey bar. So if you've ever seen a Hershey bar, this is naturally cut, I think, into, if I'm remembering correctly, 12 pieces. Because you have the 4, like if you're making a s'more, like my kids make s'mores all the time in the summer, like over a campfire. We can get like 4 s'mores out of a Hershey bar because they do the 4. Now usually, like my kids, they will we'll break it into the 4 natural breaks that they have. But even after you have those natural breaks, the 4 natural breaks, within that they have the 3 pieces, the 3 mini pieces. So usually they'll take like 1, they'll eat it, and then they'll put the 2 other ones on their s'more, and they'll keep those 2 for the s'more, and they'll eat 1. So this almost resembles a Hershey bar. You make your fraction, and again, you can do it either way. You can count how many you have first. So 1, 2, 3, 4, 5, 6, 7, 8 total, which would go on the bottom. And then you can see all but 1 are shaded, which is going to make a 7 on the top, because again, shaded number goes on top. You can see that all but 1 are shaded, which would make 7. Very similar is C. That's going to be 3 on the bottom because there's 3 total pieces on the bottom. That's going to go on the bottom for the whole or the total number, and then 2 for the shaded piece on top. All right, for D, there's 4 total pieces, only 1 is shaded, so 1/4 or 1/4. Okay, this would be like, you know, a dollar, right? Quarters for a dollar. You have 1/4. 4 quarters would make a dollar. For letter E, we have 1, 2, 3, 4, 5 shaded. And again, it's kind of, you know, you can tell if you have 5 shaded and 3 unshaded, you're going to have 8 total slices there. And that, again, is almost like your pizza pie. And letter F, we have 1, 2, 3, 4, 5 total. And we have 3 shaded. All right, so that is how we use a fraction to represent the shaded part of the object. All right, so moving down, drawing the sketch to illustrate the fractional part. So this is the exact opposite of what we did on the top. Now, I don't care how you draw it, whether you want to use a circle, a bar, a diamond, you know, an octagon, an octagonal shape, whatever floats your boat, you do you. But what you do want to make sure you do is do it as evenly as you can. So if I use a bar, I'm going to, you know, I'm going to cut in half. Then I'm going to cut those in half again. That would give me 4. And then I'm going to cut those all in half, and that's going to give me the 8 that I need. All right. And if I want 1, I'm going to shade 1. If I want 1/2, I only need 2 pieces, which means I'm going to cut the 1 in half, and I'm going to just shade one side to get 1/2. Now, for 3, I can't cut it in half because in half would give me 2, so I kind of have to, you know, be a little bit more creative. I have to cut it in thirds. I need 3 even pieces. Now, this, you know, you can tell my one looks, I mean, I did it pretty evenly, but maybe my one looks a little bit bigger. You know, it's not going to be perfect. It is an approximation, but make it as close as you can. I'm going to shade 1. Again, this one, D, will look very similar to A. We're going to cut it in half, half again, half one more time, and then we want to shade in 5. So 1, 2, 3, 4 will give you half, and then 1 more to give you 5. Fifths. Fifths is kind of like thirds. So anything odd on the bottom is going to kind of give you, you know, not the halves where you're doing it evenly, but where you have to be like a little bit more creative. So 1 more. So again, a little off there. And you only want 3 of them shaded. And then fourths. So I cut in half, and then I cut in half again. You can tell my arm's a little shaky when I get down to the bottom. I'm going to brace myself. And then 1, 2, 3. All right, on to the next page. All right, so we want to name the numerator and the denominator in each fraction and classify each as proper, improper, or a mixed number. So this is where I talked to you right at the beginning about getting a little bit more into what kind of fractions each are. So we talked about what the denominator is. Denominator means down, which means numerator is the top. So now, again, if this was a test question, you're going to want to, you know, label this more nicely, or you're going to want to label it outside of, you know, you'd want to, on a test, you'd want to say like 2 is the numerator, 5 is the denominator, And then this is a proper fraction. Now, proper fraction means the numerator is smaller than the denominator. Okay? Improper fraction means that the numerator is bigger than the denominator. And a mixed number means that there's a whole number plus a fraction. Okay? So if we're not being as formal, we can label this is our numerator, this is our denominator, and this is a proper fraction. How do we know it's proper? Because our numerator is smaller, right? This is our numerator, this is our denominator, and because our numerator is bigger, right here, this is an improper. Okay, here is our numerator, here is our denominator, and this would be an improper fraction, because again, our numerator is bigger than our denominator. Again, numerator is bigger than our denominator. This one, our numerator is smaller than our denominator, and here also. Here is our numerator. Here is our denominator. That 10 doesn't count for anything. That 10 is the whole number, and because we have a whole number, that's a whole number, that means we have a mixed number. And mixed number is exactly what it sounds like. It's a whole number and a fraction. Now, I lied a little bit, and I realized I lied just now because of the example letter F. I said that the numerator had to be greater than the denominator, but the numerator can actually be greater than or equal to be improper. So you see that here's my numerator, here's my denominator. When the numerator is equal to the denominator, this is actually improper as well, because the numerator is equal to the denominator. So when the numerator is equal to the denominator, it is improper as well. I apologize. So that is the special case. Okay, when the numerator is equal to the denominator, it is actually improper as well. All right, so Charlie drove 43 minutes to go to a Celtics game. Celtics, baseball fans. All right, I'm bungling this problem all the way up. Basketball fans will know. 17 minutes of his trip were spent in bumper-to-bumper traffic. Obviously, I'm not a basketball fan. What fractional part of his time was spent in bumper-to-bumper traffic? All right, so 17 minutes was spent in bumper-to-bumper traffic out of 43 minutes total. So remember, the total time is always going to go on the bottom, okay? The part is always going to go on the top. You're always going to simplify if you can, but we haven't really gotten to that part yet. So we're going to talk about that next. And that's it. All right, so try what you can on the independent, and I will see you at our live.